Greetings! Welcome to Pablo Hidalgo's tutorials and the new free CCNA complete training, now in English. Today, I'll present to you the lesson number 4, Physical Layer with Optical Fiber. Optical fiber cable transmits data over longer distances and at higher bandwidth than any other networking media. Fiber optic cable can transmit signals with less attenuation than copper wire and is completely immune to EMI and RFI. Its main components are core. This is the physical medium that transports optical data signals. The core is a single continuous strand of glass or plastic that is measured in microns by the size of its outer diameter. The two multimode sizes more commonly available are 50 and 62.5. Single-mode cores are generally less than 9 microns. Then we have the cladding. This is the thin layer that surrounds the fiber core and serves as a boundary that contains the light waves and causes the refraction, enabling data to travel throughout the length of the fiber segment. In multimode fiber, multiple beams from a light source move through the core at different paths. In multimode step-index fiber, the density of the core remains constant from the center to the edges. A beam of light moves through this constant density in a straight line until it reaches the interface of the core and the cladding. At the interface, there is an abrupt change due to a lower density. This alters the angle of the beam's motion. The term step index refers to this suddenness of this change, which contributes to the distortion of the signal as it passes through the fiber. A second type of fiber, called multimode graded index fiber, decreases this distortion of the signal through the cable. Density is highest at the center of the core and decreases gradually to its lowest at the edge. There are different categories of graded index multimode fiber optic cable. The TIA-EIA recognizes OM1, OM2, OM3, and OM4. OM1 and OM2 cable are not suitable for today's higher speed networks. This multimode cable is traditionally orange. Both OM3 and OM4 are designed for use with 850 nanometer lasers and have aqua sheets. The single-mode fiber itself is manufactured with a much smaller diameter than that of multimode fiber. Single-mode uses step-index fiber and a highly focused source of light that limits beams to a small range of angles, all close to the horizontal. Single-mode fiber is popular in long-distance situations spanning hundreds of kilometers, such as those required in long-haul telephony and cable TV applications. A fiber optic connector terminates the end of an optical fiber. A variety of fiber optic connectors are available. Some of the most popular connectors are the straight-tip ST connector was one of the first connector types used. Subscriber connector or SC connectors are widely adopted LAN and WAN connectors. The Lucent connector or LC connector is a smaller version of the SC connector, and their popularity is quickly growing due to their smaller size. Optical fiber patch cords are required for interconnecting infrastructure devices. The use of color distinguishes between single-mode and multi-mode patch cords. A single-mode fiber cable has a yellow jacket, and a multi-mode fiber cable has an orange or aqua jacket. To transmit between two devices, you need two cables, one for each direction. Note that the transmit port on one device connects to a cable that connects to a receive port on the other device and vice versa with the other cable. A fiber cable should be protected with a small plastic cap when not in use. To use optical fiber with Ethernet switches, you need to use a switch with either built-in ports that support a particular optical Ethernet standard, or a switch with modular ports that allow you to change the Ethernet standard used on the port. On screen, I'm showing a switch with 4 SFP Plus ports, into which you could insert any of the supported SFP Plus modules. Those SFP Plus ports support a variety of 10 gigabit per second standards. Please subscribe to the channel if you're not already a subscriber. Also, you may consider joining as a member so you may support me to continue creating more videos for all of you. For our next lesson, I will present the layer 2 of our 5-layer module, and specifically Ethernet technology used for local area networks. Thanks for viewing. See you in the next lesson. Goodbye.